In this problem, we're going to determine how many liters of oxygen can be produced from potassium chlorate based on this chemical reaction. So we have 4.8 grams of potassium chlorate, and in order to find the volume of the oxygen that can be produced, we're first going to determine how many moles of oxygen can be produced based on this chemical equation, based on the mole ratio. So if we look at the reaction, every 2 moles of potassium chlorate is giving us 3 moles of oxygen. So in order to find the moles of the oxygen first, let's find the moles of potassium chlorate. Now, so this is equal to the mass, M, divided by the molar mass of potassium chlorate. So it is 4.80 grams over 100, and so we have 22.5 grams per mole. It's the molar mass of potassium chlorate. We cancel the grams, so we have 0.0392 moles of potassium chlorate. Now let's determine how many moles of oxygen we can get from here. So let's put the moles on top of potassium chlorate and look at the mole ratio. So every 2 moles of potassium chlorate gives us 3 moles of oxygen. So in order to find the moles of the oxygen, it's cross-multiplying 3 times 0.0392, and then we're going to divide that by 2. So 3 times number of the moles of potassium chlorate, and then we're going to divide this by 2, the number of the moles, the coefficient of potassium chlorate in the chemical equation. So if we do that, then we have 0.0588 moles, and that's the moles of the oxygen. And what we need to do is this point, we're going to use the ideal gas law equation, PV. So we have for the PV is equal to nRT. And from here we can write down that the volume V is equal to the nRT, and then we're going to divide this by the pressure. Alright, so let's write down the moles. So 0.0588 moles of the oxygen, and multiply by the R, that's the value of R, and I'm going to skip the units just to keep some space here, times the temperature, which is given. It says that it's a standard condition here. So standard condition, this means that it's 0 degrees Celsius, and if we convert this to Kelvin, we're going to just add 273. So we have 273 Kelvin. I'm going to put this in the equation. So let's put here 273. and I'm going to divide this by the pressure. And we know that the pressure is also 1 atm because it's a standard condition. So standard condition means that the pressure is 1 atm and also the temperature is 0 degrees. So we're going to put all of these numbers and multiply everything together, and I'm going to get 1.32 liters of oxygen produced in this reaction.